Well, welcome to our next section in the Algebra 1 review. We're looking at Intro to Functions. Hopefully you'll really hear that song. Sometimes I have trouble with the audio when playing these songs over these videos. So let's go to our little quick or actually a cartoon of the day, I should say, another Far Side cartoon. This was one of my favorites of all time that I've seen. It was an innocent mistake, but nevertheless, a moment later, Maurice found himself receiving the full brunt of the mummy's wrath. If you can take a look at that picture and kind of get the idea of what's happening inside those stalls and where that guy is, and the mummy's next to him. He made an innocent mistake with the tissue paper or toilet paper. All right, so intro to functions. We're going to look at this section now, what a function is. There's some highlighted words here. Relation is one of the words, and function is the other word. So a relation is just pairs of inputs with outputs. So basically everything is a relation, but not everything is a function. So when a relation is given as ordered pairs, as it says here, the x coordinates are inputs, and the y coordinates are the outputs. So we know this as an ordered pair, and you should know that. It's what's called an ordered pair, an x and a y. X is always first, y is next, or second. The first part is the input. The x coordinates are the inputs, and the y coordinates would be considered called the output. And so everything, this right here, is just a set of inputs and outputs. It's a set of ordered pairs. And so that is a relation. This is a relation. A relation can be described in many different ways. It could just be like this, a set of ordered pairs. It could be described as a table of values. You know, we can make a T-chart here and table of values. We could graph this. It could be considered a graph if you plotted these points on a graph. Any of those things would be considered a relation, but a relation is not always a function. And here's what it says here. A relation that pairs each input with exactly one output is a function. So each input has to have exactly only one output. So this one, as you can see here, -1 is the input, 3 is the output. 0 is the input, 3 is the output. 1 is the input, 3 is the output. So you can see it's got a few numbers that are the same on the outputs, but it says this relation is a function. The relation is a function because every input has exactly one output. So -1 has 3. There's no other -1s that have a different number. So it's not like -1 has 3 and -1 has 5. We don't see that here. So every input, -1, 0, 1, 2, and 3, are only assigned one output. Now that output could be the same output. As you can see here, the first 3 all have the same output, but they're all different inputs. So basically what you want to realize here when you're looking at ordered pairs, all the inputs have to be different. All the x coordinates have to be a different number. If any of the x coordinates are the same number, then that would not be a function. If we look at this one, look at our x coordinates, the inputs, 5, 9, 7, 5, and 6. Notice that 5 is here twice. 5 is here, and 5 is also here. So these two right here, because 5 is there twice in the inputs, it's there twice for the x, that means it's not a function. Can't be considered a function. We could see that a couple different ways. If we're looking at a graph, we would use something called the vertical line test. We'll look at that here in a minute. Well, coming back to this song, I kind of want to just use this song kind of as a template for us understanding, what a function is. And so let's kind of go through this a little bit and see what it says here. So it starts off with the input is the set of x. So we already just saw that. The input is the x coordinates. Now, this right here, f of x, is a function notation. So input goes into the function, and that's the inputs, what you put into a function. We're going to see how we're going to evaluate that sometimes. And then it says that the output is the set of y. We talked about that too, where it is the y coordinates. That's what comes out. That's what we get out. So once we put a number into the function, we're going to get a number out of the function as well. that would be our ordered pairs that we get. Okay, so when we see those ordered pairs, the x-coordinate is the input, the y-coordinate is what we had gotten out from putting that x-coordinate in to the function. And as we keep going on to the next part, right here, it says when you do the vertical line test, and so here's where I want to talk about that real quick. We could see a function as, you know, as some kind of graph. How do we tell if this is a function? Remember, all graphs would be relations, but not all of them are going to be functions. If we take a vertical line like these dashed lines right here, and we just kind of go across the graph from left to right, if you touch this red graph twice at the same time, then it's not a function. But as long as you just are touching it once, as you can see here, these lines here, they're only going to ever touch this once. There's no place where you're touching it twice, so this would be a function. So that would be considered a function on that. Let's see, let's go on to the next part of this. Here's a couple of diagrams. You can see it could be in diagrams, it could be equation form. So here's our set of x in diagrams. So x is 1 and 2, y is a 3 and a 5. So basically how you would get those ordered pairs is 1 is paired up with 3, 2 is paired up with 5. And that would be a function because 1 is not paired up with 3 and 5. If you had this arrow going here and here, then that wouldn't be a function. Right? So you now know all the inputs can only go to one number. Now you could have had both of these numbers both going to 3, both going to the same number, and that'd be fine, as long as you don't have these two going to two separate numbers. So you could see it in equation form. A function can be in equation form, written as kind of like a, you know, somehow one of like those literal equations that we were doing earlier, or linear equations. Let's move on to the next one. The set of outputs is the range. The set of outputs, or sorry, the set of inputs is the domain. We're going to look at that here next. Called the domain. There's another word that you need to know. The domain. What is the domain? It's, you know, basically where the graph is on the x-axis. What are all the x-coordinates of this graph? And sometimes that is specific numbers, and sometimes that's a range of numbers. So then the other one, let's see where to go there. There it is. The set of outputs is the range. So there's another word. Range is another word. We know outputs is the y-coordinates. The y-coordinates is also called the range. It's where the graph is on the y-axis. All the places that it's going to touch the y-axis or touch the, you know, on the y-coordinates. So that could be, again, specific numbers, or it could be more of a range of solutions, which would be an inequality, described as an inequality like we've learned already. So when no x repeats, you'll have a function. We just talked about that. When the x is not repeating, so we saw that back in our thing here when we said, back over here, here's when no x is repeated, it was a function, but when x is repeated, right there with 5 and 5 there again, it was not a function. Let's go back here. No, I don't want that. Next thing, so the set of outputs is the range. We already saw that. Yeah, you have a function. Next part. So a function is a type of relation. We already talked about that. It is a type of relation, but a relation is not always a function. And we've talked about that too, right? That was in the song. An input may have more than one output. So that's like we said before. An input may have more than one output. Would this be a function though? No, it wouldn't, because 1 is going to 3 and 5. That's a situation where that's not a function, because 1, the input, is going to 2 outputs. So the input can only have one output. Each input can only have one output to be a function. So that would be a situation where it's not a function. Here's a different one where this function, this one would be a function like we said earlier. 1 and 2 are both going to the same output. That's okay. That's okay to be a function. So 1, 3, 2, 3, the x's don't repeat then in those ordered pairs. So when every x has exactly one y, we give it that special name of a function. That's what we give it. All right, so I just wanted to go through that so you guys could get the idea of really what we're talking about here. I thought that video was really good. I wish the audio was better than it was. All right, so let's move on to the domain and the range here. So here we were talking about domain, there's those words. So the domain of a function is a set of all possible input values, which again are the x values. Range of the function is all the set of all possible output values, which again is the y values. So it says find the domain and the range of the function here. This is a function because if we were to use the vertical line test, we're not going to touch more than one, like this is just dots here, so we're not touching more than one dot at a time with a vertical line, or right here we're not touching more than one with a vertical line going through here. So the domain is, since these are specific points, the domain is just going to be the specific numbers, all the x-coordinate numbers. So what's all the x-coordinate numbers? Well, it'll be right there, -1, 0, 1, and 2. There they are. All the y numbers are going to be the range. So what's all the y numbers? You're going to have start with the least to greatest. You get -4, 2, 0, and 2. There they are. But when it's like this, now you have a kind of a curve drawn or some kind of continuous function. This would be continuous. When it's got some kind of curve or line, you're connecting the dots in some way. This would be a discrete function, they would call it. This would be discrete, this would be continuous. Let's maybe write that word down there. So function A, this would be a discrete, like that, discrete function, because it's just point by point by point. There's just the function is just a set of points, so it's discrete. This would be what we call continuous, E-O-U-S, continuous function, because you're connecting points. So you do have the 2 points there, but they're connected with a curve, or it could be connected with a line or something like that. So if that's the case, your domain and range are going to be now an inequality. Look at the inequalities they are. They are these compound ones. X is in between 2 numbers, but where is it at? Well, there's -3 right here, and over here is +3. So on the x-axis, where is the graph on this x-axis is what the domain is asking you. Well, the domain, the graph is in between -3 and 3 on this x-axis. So you can kind of see if you were to draw this all the way here, it's between -3 and 3. So that's why they write it at that. Now notice it's always going to be less than or equal to, as long as we have closed points here. If for some reason they put an open hole, we would not have the equal to. And then for the y, where is this on the y? The range is here. It's between 2 and -2. So we want to always go less than to greater than. So -2 first to +2. So always going to, just like a number line does, right? Just like a number line. It's easy to see on the x, but on the y-axis it's vertical, so you got to realize it's always less to greater, negative to positive. And so that's why these are always got to be less than symbols in there. So that's what a continuous function would do. Let's look at our next part here. Okay, so our next part is the practice. We're going to just determine whether the relation's a function. That's easy to do for number 1. Just look and see, does x repeat? Does x repeat? So we have a 2, 3, 4, 5, 6. X does not repeat. So we can say yes. So every input has exactly one output. We might want to say that. Every input, that's y there, every input has exactly one output. And that's what makes it a function. And so we can say yes on this one. Is determine whether the relation is a function? Yes. And we could say it is a function. So number 2, so this will put function down here. That is a function. Number 2, we want to see again, does the x repeat? So you have 8, 6, 4, 2, and 4. So right there, 4 on the x repeated. So the input of 4 has 2 outputs, 2 different outputs. 4 has -7, 4 has +7. So because it doesn't meet this, every input does not have exactly one output, we would say not a function here. This one definitely not a function. This one, 3 to 5, we're looking at find the domain and the range of the function. Now it does tell us it's a function, but vertical line test would also tell us that it's a function if it's a graph here. So there is no, so vertical line does not touch it. Now if this was a circle, right, all the way around, if this kept going all the way around, a circle would not be a function because a vertical line would touch here and up here at the same time, touch two places on that circle graph. So a circle is not a function. It is a relation. But this right here, which would be a semicircle, is a function. So it says find the domain. So we want to look for the domain here. So I'm just going to put D for domain. That would be where it is on the x. So x right here, always domain is the x. Where is the graph located on the x-axis? So we got, this is -4, and over here is +4. So we start with the one on the left, the negative one. -4 is less than or equal to, because it does have closed holes there. X, we're talking about x with domain, less than or equal to +4. And then if we look for the range, I'll put R for range, and that's going to go from right here, which is -4, up to where these points are both at, which is at 0 right here. It's at 0. So -4 is less than or equal to, we've got to start with always the one at the bottom to top, right? So start with negative. And we're not going to put x here, we're going to put y. We're on the y-axis on this one. Less than or equal to 0, which is where it would stop here. It stops up here at 0. It's not above the 0. This one would be, and this would be continuous, right? We know this would be called a continuous. I'm going to put that function on this one. It's a u. This one would be called discrete. 1, 2, 3, 4, 5 points. This would be discrete. They're just separate points here. Discrete function. So our domain for this would just be all of the x's. So that would be starting here at -3. The next one we see is at -1. And we're going left to right, negative to positive, +1, 1. Next one is at +3, and the last one's at +4. And so then the range is also going to be just separate numbers here. So starting with this one, the y-axis. So starting here at -4, that's our first point. Next one's at 0. Next one is right here at 1. This one here is at 4. And this next one here is at 6, actually. Now, so actually really, I made a mistake there. Notice what's going on here with our graph. Look at this. Did this happen on this one? I don't think so. 1, 2, yeah, all by ones. 1, 2, all by ones on that one. But this one, the x-axis, every box was 1. That was -1 there. That's +1. But on the y-axis, this is 2. That's -2. And so when I did this, I got -4 right. I got 0 right on this one, but I got this point wrong here because I messed up. That should be actually +2. 4 was correct here. This would make this 6 right there. So our last number would be 6. We're going 2, 4, 6 on that. This next one would also be a continuous function. It's continuous. It's got, even though it's a V shape, it's still continuous. Got the lines on here. And so our domain for this one, where is this going to be on the x-axis? So notice this one has an arrow. It doesn't have a point. It has an arrow. So you might want to think, well, it starts right here and it ends over here. So that's actually only part of the domain, because the arrows would keep going. This really, we need to notice that this right here is like a window in your house. And you're only going to see a certain amount of the outside when you're on the inside of the house. But there's a whole great outdoors, right, that we know there's more stuff above this window. If we can see maybe the trunk of the tree, well, we know the leaves of the tree are going to be up here. We know that. So you got to realize that this would keep on going. This V shape is going to keep on going. We're going to end up being at -4, a little bit higher, -5, a little bit higher. So because of that, it doesn't start and stop at those numbers. Because of the arrows, it's going to just keep going forever and ever, each direction. So in this case, we want to say it's going to be all the negative numbers. It's going to keep going this way forever, ever, keep going this way. So we want to say it's from infinity, from negative infinity, less than or equal to x, less than or equal to positive infinity. And we might not even actually have to put those equal to signs. It doesn't matter on this one. But basically from negative infinity to positive infinity, we can do that. We can also say it like this, all real numbers. That's another way you can say the same thing. I'm going to put a number sign there for numbers. So it can be this inequality with negative infinity to positive infinity with x in the middle, or you could say all real numbers. Now the range, this one's a little bit different because it definitely starts at 0. But where does it end? It doesn't. It keeps going to positive infinity. So in this one, we could do it this way. We could say from 0 is less than or equal to x is less than or equal to positive infinity. And we might want to put positive sign on that one. That's fine, or just the infinity symbol. The infinity symbol is the sideways 8, as you can see I'm writing here. Or another way we can say this is we could just say that x, or we could say it with a y. It's actually, sorry, not the x there. We would want to put y in there. That was my mistake. Put a y there. We could also say it this way, that y is greater than or equal to 0. And that's actually probably the better way of doing it, honestly. That's the way you're probably going to see it most often, where you just say, okay, where is the graph on the y-axis? Well, it's just above 0. It's everything above 0. It includes 0 because it's right there. It hits 0, includes 0, so it's y is greater than or equal to 0. That's the best way to do that. This would be more another way you could see it, but I would say this is the better way to actually write it. And this one, probably all real numbers, again, is maybe the best way, though you're going to probably see that more often than with the infinity symbols, even though this is also correct. All right, let's move on to the next section. Before we do that, let's do our joke of the day. Here we go. Did you hear about the guy who dreamed he was eating a giant marshmallow? He dreamed he was eating a giant marshmallow. When he woke up, his pillow was gone. Wonder what happened. All right, so function notation, we talked about that in the video, that f of x. There's your function notation. That's what function notation is. Basically, f of x is the same thing as saying y. So you can say that f of x is the same thing as y. It means the y equals. So f of x equals, right here, if I did that, f of x equals some expression. That's your function part. So this would be the function here, whatever the equation is or the function is. It's the same thing as saying y equals that function. A lot of times you've seen this right here, y equals mx plus b. That's a linear function. Well, you can do this. F of x equals mx plus b. Notice the mx plus b part is the same. That is the function part. This is the function part right here. This is just the notation. You could be in function notation or just more, in y notation. This would be more like coordinate notation maybe. So don't be alarmed by the f of x. You're going to also see it like this with g of x. So these letters often change, and the reason why they change is so that we can talk about more than one function at the same time by giving it different names. So the name of this one's f, the name of this one's g. The letter in here does not change because it's the same letter that's in the function. So whatever letter is in the function, x is in this function, x is going to be in this parenthesis. So if we had a t in this function, well, t would be in the parenthesis. All right, so it says evaluate the function for the given value of x. All it means to do is just you're going to plug in 7 on this one where x is. So we've kind of done that already a little bit in the past. On our first video, I think it was. We're just going to plug that in, evaluate, figure out what that is. So if 7 is the input, right, this would be your input right here. So the input is 7. This would be our output down here, which would give us really an ordered pair. And you can write this as an ordered pair. 7 would be the input, and what this is, 19 would be the output. There's our ordered pair. So when x is 7, f of x equals 19. You need to realize that that's still an ordered pair. 7 is the x coordinate. 19 is the y coordinate, y equals 19. Same thing over here. You can make this a -3 is the input number. You're going to put that into the function and then work it out with order of operations pretty much. And then you're going to go ahead and figure out that 21 is the output. That's the y-coordinate of the function. All right, here's a couple more. Determine whether the ordered pair is a solution to the equation. So here's now it gives you an ordered pair, which is going to give you an x number and a y number. And what you want to do here, if h of x is the y, so y is going to go for h of x. So this is basically your h of x on this one. Now it's going to go here too. And then 6 is the x, or -6 is the x that goes there. You just figure out, does this side equal 2? And since it did, you could say, yes, it's a solution. Plugging this one into this absolute value, well, that didn't work out. -7 does not equal +7, so no, that ordered pair is not a solution. So you just want to plug these in. So this would be your x going in here. This would be your p of x. -7 is the p of x going over here. So you're just going to substitute in and then work it out to see, does one side equal the other side. Okay, so here's some to practice. Let's go ahead and practice some of these together, and then I'll have you do some of these on your own. So let's go ahead and try number 2. We're going to plug in -1 for x and see if it equals this other side. I'm sorry, that's not what we're going to do here. We're going to evaluate the function for the given value of x. All we got to do is just plug it in and find out what does the g of x equal. Here's where we're deciding if it's a solution. So -1 goes in, we're going to see, okay, it's going to be 6 minus 5. Okay, 6 minus 5, and then in parentheses, you have to put this in the parenthesis in the function. So -1 goes in here. So we need to see that -1 is going to multiply -5. Negative times negative is positive. So what that's going to become is 6 plus 5. And so what our g of x is going to equal here, g of x then will equal 11. There's our g of x. G of x is equal to 11. So the given value, that's our input is -1, the output is 11. So you can write it as an ordered pair, which would be -1, comma 11. That would be our ordered pair. Let's try number 4. Plug in -2. So we're going to see a negative sign here first, and then in for x, this negative sign does not go for that one. So you have a negative sign, then parenthesis, where the x is -2. So there's going to be now 2 negatives making positive right there, -4. So that's going to give us +2 minus 4. So we can see on this one, n of x is going to equal -2. And so again, our ordered pair, if we wanted to write that as ordered pair, that would be -2, comma -2 would be the ordered pair. This one for 6 is going to go in here, so it's going to be, write this on the side over here, -3/4. We're going to plug in 6 right here, and then we're going to square the 6. We're only going to square the 6 because we're only squaring the x in here. Actually, yeah, -3/4 is right. Negatives in front. Almost thought I forgot the negative sign, but no, I didn't. So 6 squared is 6 times 6. Whenever you're squaring something, multiply it by itself. So 6 times 6 is 36. This is going to make -3/4 times a 36. And you might want to put that over 1, and we can cross cancel 4 and 36. 4 goes into 36. 4 goes into itself once. Let's do that. 4 goes into 36 9 times. So now we can say, okay, p of x, what's p of x actually going to equal here? Well, it's just -3 times 9 because we have 1s on the bottom. So -3 times 9 is -27. And it would be 6 comma -27 for our ordered pair. Plug it in here. -3 goes into actually 2 places. So we're going to see x squared, so it's going to be -3 squared. Put that in parentheses. Always what you're inputting in, put it into a parenthesis. And then 7 times, and then parenthesis, input -3, and then -1. So for the first part, -3 times -3 is going to give us 9 here. 7 times -3 is -21, -1. And then these 3 numbers here, 9 minus 21. We might want to put the 2 negatives together first. That might be easier. So 9 minus 22. because we can add the two that have the same sign. So if I take 9 away from 22, it's going to give me, 13. So we're going to see this one, k, I'll just put it over here, k of x will equal a negative 13 because 22 is bigger. So negative 13, there is our answer. Go ahead and put that in a little box. We can box our answers here. Should do that. G of x equals 11 up here. We said p of x equals negative 27 down there. This one we have an absolute value. Let's talk about that one. Plug in 1 still in here, so it's going to be the absolute value of 3 times 1 minus 8. Oops, no parentheses, absolute value sign. So first of all, just do what's inside the absolute value symbols, and then we'll talk about what we have after that. So this is going to just be 3 times 1, which is 3. So absolute value of 3 minus an 8. And we'll just do that, 3 minus 8, so it's going to be absolute value of negative 5. So when you see now the absolute value symbols, and you have just one number inside there, whatever number that is, it has to turn positive. So to get rid of the absolute value symbols, you just turn this positive. If it's already positive, then it stays positive. But if this number is a negative like we have here, then it's just going to equal positive 5. So our h of x here on this one is equaling 5. That's our answer for this guy. All right, so you're going to finish up. You're going to do number 1, 3, 6, and 9 on these. But let's go on down to here and do these other highlighted ones. We're determining whether the ordered pair is a solution of the equation. So again, this would be our x that we're going to plug in here. This is going to be our h of x. So 19, and I'll put it on the side over here. So it's going to be negative 19 equals, because it was h of x equals, 7 times, I'll put in parentheses my x here, negative 3, minus 2. So we just got to do this side and see, does it equal negative 19? So we're going to see 7 times negative 3 is negative 21, minus 2, that's going to give us negative 23, which is not the same thing. So if I put 19 right here, put a slash through my equal sign, it doesn't equal. So this one would definitely be a no. That is not a solution. Let's go on to number 12. Let's do the same thing here. We have, this is our x, and this would be our g of x. And so I'll do it on the side over here. So we have negative, and then we're going to say x is, actually sorry, I got to put my g of x down first. Forgot about that. Where are you at? There you go. So put g of x first. The g of x is 25. So 25 equals. And then we'll put negative, and then the negative 5 in parentheses. Negative 5 in parentheses, and we're going to square that. And then we're going to add it to negative 5. I'm going to put that in parentheses again. Always put your inputs in parentheses. It's a good habit. And then we still have this plus 5 to put on the end. So now we're going to see, does all of this, when I simplify this with the order of operations, does it equal 25? So let's go ahead and find this out here. So first of all, I do not do negative times negative. I need to do the squared part first. Exponent first before you multiply. That's always what order operations is going to do. So negative 5 times negative 5 is positive 25. And then we're going to multiply it by negative, making it back to a negative 25. You see, if I did it the wrong way, if I said negative times negative first, and then I just said 5 squared, that would give me positive 25, and I would get the sign wrong. Over here I have positive times negative, which is negative 5, and then we still have the plus 5. Well, 5 and negative 5, these two I know are going to cancel each other out. So we have our 25 is equal to negative 25. So that is not correct. 25 does not equal negative 25. So 12 is also no. That's not a solution. Wasn't a solution. Let's go on to 15 with absolute value symbols. So this would be our x. Here is our p of x right there, the 2. So let's go on the side here, start with 2. 2 is equal to the absolute value, negative 9 times x, which would be 0, minus 2. And so let's go ahead and figure out what's inside the absolute value symbols and see if it equals 2. So negative 9 times 0 would be 0. So 0 minus 2 there. And so that's going to end up being 0 minus 2 would be negative 2. And so the absolute value of -2 is always positive. It's 2. So 2 does equal 2. That works. So we can say on this one, yes. We got a yes on this one finally. 15, yes, that is a solution to that function. Now let's try 16, our last one here. It says the function c of x is equal to 49.5x plus 19.5. It represents the cost in dollars of buying x concert tickets. So how much does it cost to buy 4 tickets? How many tickets can you buy with $465? So the number of tickets is the x. X is concert tickets. X is the number of tickets. And this one says, you know, how much does it cost to buy 4 tickets? So that means you're going to input 4 on this one. So this would mean right here, input 4. That's what we're going to do, 4x. So we're going to input the 4. I'm going to raise this up a little bit so we can do this last problem. Give myself a little more space. And then you're going to be finishing up 10, 13, and 14 when we're finished with this one. So if I do that, we're going to just say, okay, c of x is equal to 49.5 times 4, put that in parentheses, plus 19.5. And so we can do this on a calculator. The numbers are a little bit bigger. I'll grab my calculator here. So we have 49.5 times 4. That's going to give us 198. So 198 plus a 19.5. So just add that in there, plus 19.5. That gives us 217.5. So our cost here, C of X, would equal, and we could put a dollar amount here, $217.50. So there's our answer for that first part of that problem. Over here it says how many tickets, let's put my calculator there, how many tickets can you buy with $465? Well, in that case, our C of X, this would equal right here our C of X. That's the total cost. And so we want to figure out the number of tickets. We want to solve for X. So we got our 465 is equal to 49.5x plus 19.5. And so we're just going to solve this equation like we did a couple videos ago, lessons ago. So we're going to first subtract, get this by itself, subtract. I see addition, I'm going to subtract 19.5 from both sides. 19.5. I'll use my calculator. 465 minus a 19.5 is 445.5 equal to a 49.5x. Now I just need to divide by 49.5. That's what we're going to divide by. So now we can find out what our x is and figure out how many tickets we could buy with $465. So I'm going to take that and I'm going to divide by my 49.5, and that equals 9. So that means we have 9 tickets that we can buy. We want to put the word tickets there because that's what that's talking about. So 9 tickets on that one. This would be our answer here in dollar amount. Alright, so that concludes this lesson, but stay tuned for more review lessons as we continue to review Algebra 1 before we get into our Algebra 2 stuff. Alright, I'll see you next session.